Now let us understand APIs related to aggregations, ranking, and windowing functions. So here I'm launching Spark Shell as part of the window machine. I'm launching Ubuntu here, or we can actually launch SBT console also. So whatever is convenient to you, you can start with that. Let me launch SBT console by going to Mount C users, Digadraju, idea projects, and then Spark demo. So that is the directory name. Here I'm saying SBT console, but before saying SBT console, let me review the build.sbt. So here you can see that this build.sbt have only Spark core. It doesn't have Spark SQL. The reason was when I actually tried to connect to this machine last week, it did not work, and hence I have demonstrated using my Mac. So I have updated the build.sbt on my Mac, but not on the Windows PC. So let me first fix that issue. To use data frames, we need to have package called Spark-SQL, not Spark core, and we need to save this. As it is taking time, I will be using Spark Shell for now, but once it is downloaded, we can use SBT console also. SBT console will actually give us the approach where we can come up with the code in a application development approach, where we will be creating Spark session manually, and then we will import all the necessary APIs, and we'll be start using those things as part of the code. However, with Spark Shell, Spark session is pre-configured. We will get Spark session object automatically, and we should be able to use it directly to read the data and process it. However, that is not that relevant at this time. We will primarily focus on the package which actually give us the capability to perform window functions. Now the Spark Shell is launched. So the main package for the window functions is nothing but org.apache.spark.sql.expressions. And if you say dot and hit tab, you will see bunch of APIs here. One of the API is window and the other one is WindowSpec. These two are the important ones which we should focus on for coming up with logic using window functions. Here I am importing everything. So if you look at window, there are APIs such as orderBy, partitionBy, range between, rows between, unbounded following, unbounded preceding, etc. Typically, we use partitionBy or orderBy or both. In most of the cases, we'll be using these things. In some extreme scenarios, we'll be using something like range between, rows between, unbounded following, unbounded preceding, etc. For window functions, the main APIs are nothing but orderBy and partitionBy. If it is aggregations, we only use partitionBy. If it is ranking or window functions, we use both partitionBy and orderBy. And when you use these APIs such as partitionBy, if you actually look at the syntax, it takes regular strings for column names, and also you can actually pass column type column names also. So either you can pass string type column names or column type column names, the way we have seen earlier as well. So here, let's say I want to partition by some random column from our data set. We have orders, order items, etc. And let's say I want to group by order date and perform certain aggregations on top of it. So we have to specify that field here. It will not validate immediately. It will just build the spec for us. And if you hit enter, it will actually show that it returns window spec type object. Okay. Again, once you partition by, if you want to sort the data, you can actually sort by using order by within each partition. We will see the examples and it will start making sense for you. For now, I just want to highlight the main package, which is nothing but org.apache.spark.sql.expressions, and the classes which we typically use to perform the window functions or rank functions for our problem statements, which we'll be seeing later. And the main APIs are nothing but partition by and group by. They are available on top of window. And when you actually invoke these functions, it returns an object of type window spec. Okay. So that being said, when it comes to the overall functions, they are divided into ranking, aggregations, and window functions. So ranking functions are nothing but rank, dense rank, and aggregations are nothing but sum, average, min, max. Window functions are nothing but lead and lag. Now we need to understand from where we can actually get these functions. So here, if you actually say import org.apache.spark.sql.functions and hit tab, you see all the functions which I have mentioned in this package itself. You have ranking functions such as dense rank, aggregate functions such as average, sum. Somewhere you will be finding min and max also. So min, max. Window functions such as lead, lag, etc. So all the functions are available as part of this package only. So let us import this. And now if I try to read the data, let me read orders data just for showing you examples. In this case, let's say we use spark.read.json, and let me give the path as mntc data retail underscore db underscore json and then orders. It will read the orders data which is in JSON format into the data frame called orders in this case. Now if I try to use rank as part of the select, so typically we use these functions as part of select or with column or select expression. So let's try to use select in this case. And if you look at the APIs after typing rank, and if you say dot and if you hit tab, there are APIs available available on top of these functions, and one of the API is nothing but over. Okay, so we have to use this over, and then if you look at the syntax of over, there are two overloaded functions for over. One which doesn't take any arguments, second one which take window spec type of argument. So whatever spec we have created earlier can be passed here, and we should be able to perform the any of the analytic, rank, or aggregate functions using this over and window spec. So we can define the spec directly here also. So we don't need to pre-create a variable and pass that variable as argument which is of type window spec. We can directly say window.partitionBy, give the column you want, let's say order date, and then again you can say order by, and you can give the column you want. Let's give the column name as order customer ID, and on top of this we can again perform ascending or descending to get the rank. So like this we actually develop the develop the solutions for the problems where window functions are required. We will see more realistic examples as we proceed further. In this case I am just highlighting the syntax. Okay, so that being said, let us see a simple example here which will make sense for you, and then we'll actually delve deep into all the APIs as we proceed further. So in this case I am reading order items to dataset using spark.read.json, and the location is nothing but mntc users, sorry, not users, data retail db json, and then order items. Now order items is a data frame, and I just want to get the output in such a way that I get all the fields for each and every record. For example, if I say order items.show, you got all the 6 fields which are part of this data frame, which are nothing but order items, order item order ID, order item product ID, order item product price, order item quantity, order item subtotal. So let's do one thing. Let's drop some of the fields here which are not required. So I don't want order item quantity. Also I don't want order item product price. Also order item product ID. I don't want these 3 fields. So let us see the output here. Now we are getting only order item ID, order item order ID, order item subtotal. Now if you look at this, let's take the example of the these 3 records which belong to order ID 2. We got order item subtotal for each and every record. To compute revenue for each order, we can just say, let me assign this to a variable, and then we'll take it further. I am creating a data frame with the same name. Okay, I think it is not possible in Scala, but in Python you can do that. I am giving the name as order items df. Now if you want to get revenue for each order ID, it's pretty straightforward. You just say order items df dot group by order item order ID, and then sum of order item subtotal. This is the standard approach where we can get revenue for each order ID in our dataset. If you actually sort the data, you can see that for order ID 2 there is only one record, and it is nothing but the total of all the order item subtotals for that order ID. Now instead of just getting this one, I want to get the other information also. So for each and every order ID, I want to get not only the total but also the individual records. If I am able to get that, what I can do, I can actually compare each individual record with the total, and I can actually say what is the percentage of each individual order item subtotal with the total order item subtotal, so on and so forth. So we can actually solve those kind of problems when we get not just one record but all the 3 records along with the total. Total will be the same for all the 3 records, but we will have the other information also from our order items dataset. Using group by, it is not very straightforward. You have to first group by the data, and then you have to self join, and then you should be able to get the results. So in this case, if you want to use this information and if you want to get all the other information, now you can actually join this with order items again, and you should be able to get whatever information from order items along with this. It is tricky, and also from the performance perspective, it is not very good. For both performance perspective as well as for better development approach, we typically can use the window functions and solve this problem very easily. So to solve the problem with window functions, first, as I have explained earlier, we have to import org.apache.spark.sql.expressions. Once that is done, I am also setting a environment variable called spark.sql.shuffle.partitions to 2. Otherwise, it might use 200 threads when we run queries which require shuffling. Now I can say val spec equal to window.partitionBy order item order ID. So here it will not validate anything. It will just build the spec. Once you do that, so for aggregations, we don't need to use order by and sort the data. Just grouping data using partition by is good enough. Now I can say order items with revenue. This is the variable name. On top of order items, we can invoke with column. So I want to get all the columns and then this additional column. So in this case, let me change it to order items df, because df have only 3 fields. Order items have 6 fields. I don't want to use all this order items which have 6 fields, because the output will not be that readable. For that reason only, I have dropped 3 fields from order items and created this new data frame called order items df. Let us use this and then invoke with column. So we will get all the 3 columns plus whatever column we are actually defining here, as long as the column name is different from the 3 columns which we already have. So in this case, I am naming it as order revenue. The existing columns are order item ID, order item order ID, and order item subtotal. Those 3 are the fields which we got. Now we will be seeing the 4th field, order revenue, and the logic for this 4th field is nothing but sum of order item subtotal over spec, and then hit enter. Now order items with revenue dot print schema gives the schema details. It has 4 fields: ID, order ID, subtotal, and revenue. If you want to preview the data, you can actually say show here, and now you can see that for each and every order item order ID, we got all the 3 records, or whatever number of records we have, and along with the individual order item subtotal, we also got the order revenue. For all the 3 records, order revenue is same, whereas the order item subtotal is different for each of these order items for order ID 2, and hence we got these results. Now if I want to see the strike rate between order item subtotal and the order revenue for the given order ID, I just have to divide this value with this, and you will be getting what is the percentage of this order item subtotal within this order ID when we compare to order revenue belonging to this order ID. So all these kind of problem statements can be easily solved using this data set. Okay, so that being said, when we actually come up with the logic, as I have explained earlier, we can define the partition by logic directly here as well, like this: window.partitionBy, and then order item order ID. I think I missed some bracket. Now you see it worked without any issues. We can actually preview the data by saying sort order item ID dot show. Now you can see the results, and we got all the 3 fields from order items DS, and then this order revenue. So this is how we can use the window functions or analytic functions. The terms are different in different database technologies. When it comes to data frames, we try to term it as window functions because the main API is named as window and WindowSpec, which have the other APIs such as partitionBy, orderBy, etc. So probably in Spark data frames, we can use the term window functions for everything. But in databases like Oracle, we call it as analytics functions. As part of analytics functions, we can perform ranking, aggregations, as well as windowing. So depending upon the underlying database technology you are using, the terms are a bit different, but the concepts and the APIs are almost same.